Guys, let's look at this problem right here. This question is asking a charged capacitor is connected to an ideal inductor to form an LC circuit with a frequency of oscillation f is equal to 1.6 Hz. At time t is equal to 0, the capacitor is fully charged. At a given instant later, the charge on the capacitor is measured to be 3 microcoulomb and the current in the circuit is equal to 76 microampere. The question is asking what is the maximum charge of the capacitor. So this is the main question. Okay, what is the maximum charge of the capacitor? Give your answer in microcoulomb with 2 decimal places. Okay, now we are trying to find the capital Q. This is the maximum charge of the capacitor, and here we have two informations available. We have the capacitor, the charge on the capacitor is 3 microcoulomb and the current in the circuit is equal to 76 microampere. Using these two, we can create equation. For the charge on the capacitor can be expressed as Q is equal to capital Q cos omega t. Okay, this capital Q represents the maximum charge. Let's note this one down. Maximum charge on the capacitor. This is what we are trying to find. Maximum charge on the capacitor. Okay, now small q is equal to capital Q cos omega t, and also we have another information available, that is current in the circuit. That is going to be the derivative of this one. If we take the derivative, let's say current is I is going to be equal to dq by dt, and if you take the derivative of this one, this is going to be negative sine omega t, because derivative of course is negative sine, so this is going to be negative sine omega t, and since we are taking the derivative with respect to t, this is going to be t is going to become 1, and the inside derivative, I'm talking about the inside derivative because when we take the derivative, this is going to be a chain rule. So outside derivative is going to be negative sine omega t, and the inside derivative is going to be just omega. Okay, so this is going to give us negative q omega sine omega t. Now from this one we can create equation, because we know that dq by dt is current that is provided 76 microampere. Okay, for the first one we know that is 3 microcoulomb. Now using this, let's create the equation, but before we do that, we can find one more thing. If you notice here we have the frequency, so we can find the omega too. Like to find the omega, we use omega is equal to 2 pi f, and 2 pi is approximately 6.28, and the frequency is given, that is 1.6 Hertz. And if you multiply these two together, you will end up with 10.05 radians per second. Okay, now we have the omega, so we can go ahead and create the equations. Now let's create the equation for the charge. So that's going to be 3 microcoulomb is the charge on the capacitor. Let's note this one down. Charge, this is charge on the capacitor, and the bottom one is current in the circuit. Current in the circuit. Now I'm creating the equation for the charge on the capacitor, that is 3 microcoulomb, that is equivalent to Q cos omega t. And for the current in the circuit, we know the current in the circuit is provided, that is 76 microampere. So this is going to be 76 microampere is equal to negative Q. Instead of this omega, I am plugging this value because we found out the omega already, that is 10.05. And here we are going to have sine omega t. I'm keeping the inside omega t as it is because we are going to find out omega t all together. In that way it will be easier to calculate, right? We are trying to find Q, that's the main purpose. Now let's see how we can find it. So let's say this is equation 1, and let's say this is equation 2, and if you divide the 2 by 1, if you divide equation 2 by 1, you will get tan omega t. I'm just keeping this tan all together because when you divide sine by cos, that's going to be tan. So tan omega t, and I'm moving these other things to other side. So first this 2 is going to be on top, right? This 76 is going to be on top. 76 divided by 3 multiply, and this one is going to be divided by 10.05. okay, and if you calculate this one, you will get negative 2.521. so we know that tan omega t, we found out that tan omega t is equal to negative 2.521. Therefore omega t is going to be equal to tan inverse negative 2.521. So when you do this one, you have to turn your calculator into radians, right? If you turn into degree, it doesn't work. You will get wrong answers. So you have to convert this one into radians and you have to calculate this. When you do that, you will get 0. No, this is going to become negative 1.193 radians. So this is our omega t. Now after we find out omega t, we can plug it in one of this equation to solve for q. The best equation we can plug it in is this first equation because that's simpler. So let's go ahead and do that here. So this is going to be 3 microcoulomb is equal to q cos omega t. Instead of omega t, I'm going to plug this value. That's going to be negative 1.193, and you still have to keep this one in radians. And if you calculate this one, you will get q times 0.369, and in the other side we have 3 microcoulomb. And if you solve for q, you will end up with q is equal to 8.13 microcoulomb, and that's going to be the final answer. Let's write this one down on top. Q is equal to 8.13 microcoulomb. That's our final answer. I hope this helps. Thanks for watching.